Good morning, friends. In the previous class of engineering graphics, you have come across two problems on development of lateral surfaces. In today's class, I am going to discuss once again two problems. One is on pentagonal pyramid and another one is on a cone. So both are little bit different, but the problems are very simple. So understand the procedure properly and understand how to draw or how to develop the part. So that one I am going to discuss in today's class. So two problems, one is on pentagonal pyramid and another one is on the cone. So I will go through the problem statement. I am going to solve the problem number 25 and problem number 41 from VTU primer. Once again I will repeat, I am going to solve two problems. First problem is from VTU primer and that problem number is 25, and second one is problem number 41 from VTU primer. So both the problems will be from VTU primer only. So after going through this video, if you have any doubts, you can ask the doubts whatever you have by calling us. So the problem statement is a pentagonal pyramid, 30 mm sides with a side of base perpendicular to VP. Draw the development of the lateral surfaces of the retained portion of the pyramid shown by the dark lines in the following figure. Once again I will read the question. Please understand. A pentagonal pyramid, 30 mm sides with a side of base perpendicular to VP. Draw the development of the lateral surface of the retained portion of the pyramid shown by the dark lines in the following figure. So here in this particular problem, VP and HP is known to you. Above XY line is VP and below XY line is HP. So whatever we are going to draw on HP is nothing but it is the top view, and whatever we are going to draw in VP is nothing but it is the front view. So there are two chances, either the front view and top view figure may be given to you, or in some of the cases the top view is given, but for front view the figure will not be given. The problem statement may be given. So using the problem statement you have to draw the front view, or in some of the cases directly the figure for the front view as well as top view both will be given to you. If both the figures are given for top view and front view, the work will be little bit less. If it is not given, then you have to draw first the front view, and top view is not given, that also you have to draw, and then you have to go for the development. So what is given in the problem statement? A pentagonal pyramid, 30 mm sides. So pentagonal pyramid, so it means it is a top view because he is giving us the dimension of the side. So when I observe from the pentagon from the top, then I can observe its dimension and I can say that the sides are having a length of 30 mm. But if I see from the front, it is not possible for me to tell what is the length of the side. So from the front view, I can observe the height of the pyramid, but from the top, I can observe the cross section or the dimensions of the sides of the pyramid. So first what is given? A pentagonal pyramid, 30 mm sides of base. So first what you have to do is, as usual, first draw the XY line. As usual, first draw the XY line. So this much is not necessary. So this is sufficient. First draw the XY line and then mark VP and HP. So I am going to mark VP and HP. Now we need to construct the pentagon. Even though it is given in the problem statement, let us go for the construction of the pentagon. So before going for construction of the pentagon, just go through the problem statement. What it is saying: a pentagonal pyramid 30 mm sides with a side of base perpendicular to VP. A side of base perpendicular to VP. So perpendicular to VP means like this I have to draw. So now pentagon is ready. So you can find out the center. So first, before going for finding out the center, mark the points. I will mark this point as A, this point as B, this point as C, this point as D, and this point as E. So now you can find out the center of the pyramid by drawing a perpendicular from any of the corners. So from this point I will draw one projection line. So from all the points take the projections till the XY line. The projection line should be a very thin line, as you have already understood. What should be the thickness of the projection line, what should be the thickness of the pentagon which you have drawn. Everything is taught to you in your class. So this is O and this is O1. So O and O1 I am going to mark. So now from this point take the axis, but what is the length? So at what length I have to draw the axis? For that it is given in the problem statement. In the problem statement the length of the axis or the height from the front view is not given, but it is shown in the problem statement. So the height of the pyramid is 60. The height of the pyramid is 60. So draw a 60 mm chain line. So this is 60. I will call this as O dash. I will call this as O dash. This is my O dash. Now from all the points draw from all the points, whatever the projection lines you have taken till XY line, from those points join to the apex point, that is O dash. So this part is over. So now mark the points. The observer will be here. So when the observer is here, so what are the points he can observe? He can observe A, he can observe B, he can observe C in the front view, but it is not possible to observe D and E. So A dash, B dash and C dash will be outside the bracket and E dash will be inside the bracket. O1 dash is inside the bracket and D dash is also inside the bracket. So this part is over. So we have drawn the top view as well as the front view. So both the views are over. Now mark the dimensions. So each side is having a dimension of 25 mm. So mark the dimension as 25. Then next, what is the height of the axis? The height of the axis is shown in the problem statement, that it is having a length of 60 mm. So show the height from the front view that it is having a length of 60 mm. So now your top view as well as the front view is ready. So once the top view and front view is ready, then next go for the cutting edge. So cutting edge is also directly given in the problem statement, not in the problem statement, but the figure is mentioned in that the cutting edge is also shown. So the cutting edge is as it is So this is the cutting edge what they have shown in the problem. Some of the cases it is shown and in some of the cases it may not be shown. The problem statement may be given, so where you have to cut the cutting edge. So based on the problem statement you have to draw it, but in the present problem in the figure everything is directly given. So what is the angle, that is also given here. This angle is given. This angle is also given. So the angle given is 60 degrees. This angle given is 60 degrees. So this bottom portion, wherever the cutting edge is there, its bottom portion we need to develop. Its bottom portion we need to develop. The dark lines, whatever I am drawing right now with the yellow chalk, that has to be developed. That has to be developed. So this bottom portion from the cutting edge has to be entirely developed. So it is very simple. How to understand is, so when I observe from the top, I can observe a pentagon having a sides of 25 mm. When I observe from the front, I can observe the height of the pyramid, that is 60 mm. So here at a distance of 30 mm there is a cutting edge. So this is given in the problem figure itself. At a distance of 30 mm there is a cutting edge. So when I cut at a distance of 30 mm and then at a particular angle of 60 degrees, whatever the bottom portion is remaining, so after cutting this entire portion is removed, that is the upper portion, only the bottom portion is removed. If I open that pyramid, how the development will look, or if I open that pyramid, how it is going to be look. So that is what I need to draw. So there is a, now we need to understand which one is the true length. So any radial line, we need to observe any radial line which is parallel to xy line. Any radial line which is parallel to xy line, with respect to that line will be considered as a true length. So this is our true length. So O dash to C dash is considered as true length. The length, that is the true length, is having a dimension of 65.2 mm. So OC is parallel to XY line. So O dash to C dash is considered as true length. If here I was having any point, say for example I have the point H, suppose now the point is not there. If suppose there is a point H which is also, OH is also parallel to the XY line, then O dash to A dash can be considered as a true length. So now there is no any point, so do not worry about it. Now the parallel line to XY is OC, so O dash to C dash is considered as true length. So that true length we need to use while development of the given pyramid. So first what you have to do is mark anywhere beside this figure, mark a point, say O dash or O, and then you know the true length. The true length is 65.2 mm. So from O dash, draw a true length of 65.2 mm, random length. Sorry, not random length, a true length of 65.2 mm. So this length I will call this as 65.2 mm. That is true length. This length I will call it as true length. Now taking O dash, and I will mark this point as A. I will mark this point as A, the end point. The starting point is O dash and I will mark the end point, that is at a distance of 65.2 mm, wherever the line ends, I will mark this point as A. Taking O dash to A as your radius, with the help of compass take this as radius and draw an arc. Draw an arc. So once you complete the arc, then all the points on the pentagon, that is the corner points A, B, C, D and E has to be placed on that arc. So now measure A to B and cut an arc, and I will call this point as B. Similarly, measure B to C and cut an arc, and I will call this point as C. Then measure C to D and cut an arc, I will call this point as D. Then measure D to E and cut an arc, and I will call this point as E. Then measure E to A and cut an arc, so I will call this point as A. So now all the points we have marked on that arc of 65.2 mm. So on this arc, whatever the points you have mentioned, so all the points you need to join to apex point, that is O dash. So B to C, D to O, then O to E, then E to A. So all the points have been joined now. Now at this particular point, the cutting edge is changing its direction. Up till this point, that is from O dash to A dash, whatever the line is there, on that line the cutting edge is started, but at the axis it is changing its angle, it is changing its direction. So draw one line, so extend this line and mark the points. So I will mark this point as F and I will mark this point as G. Similarly, measure A to F and mark the point, so I will call this as F. And similarly, measure D to G and place it on between D to G, and also join from F to O and also join from G to O. So all the points have been marked now. Now we need to go for the development. So the first point is A. So this point. So now all the points have to be relocated to the true length. All the points have now to be relocated on the true length. So this is A. So I will relocate on the true length and I will measure, and I will call this as 1 dash. I will call this as 1 dash, and I will measure O dash to 1 dash and place it on A. And place it on A. And I will call this as 1 dash. Next, there is a line from F and which cuts the cutting edge here, and I will once again relocate it to the true length, and I will call this as 2 dash, and I will measure from O dash to 2 dash, and that line is for F, and on F line I am going to draw 2 dash. Next, take the projection line from B. The projection line from B and D are same line in our figure. So where it is going to cut on the projection line of B? Here, and relocate it to the true length, and I will call this as 3 dash. Now measure O dash to 3 dash and place it on O dash and B. So this is our 3 dash. Next is point C. So this is the projection line of C. So from here we have drawn till O dash. So where it is going to cut on C? So here it is going to cut on C, and I will mark it as 4 dash. So measure O dash to 4 dash and place it on O dash and C line, and I will call it as 4 dash. Next, from on D, on the line of D, where the cutting edge is going to cut? So here it is going to cut. So I will call this as 5 dash, relocate it on the true length line, and I will call this as 5 dash. Similarly, there is a line from G. So where it is cutting the cutting edge? So here, so from here relocate it on the true length, and I will call it as 6 dash and place it on G line, O dash to G line. The next point is E. So this is the projection line, sorry, this is the line for point E. So relocate it on the true length, and I will call this as 7 dash. Measure O dash to 7 dash and place it on O dash to E. Then similarly, the last point is the projection line of A. So here transfer the point A on the true length. So already the line is there. Measure O dash to 1 dash and place it here. I will be calling it as 1 dash. So now all the points have been marked. The next step is we need to join the points A to B, B to C, C to D, D to E, and E to A once again. But as it is a polygon, we need to join all the points with the straight line. We need to join all the points with the straight line. So join A to B and F, then B to C, then C to D, then D to G, G to E, and E to A. So all the points, once all the points are joined, so you can trim this arc whatever initially you have drawn. You can trim the arc initially whatever you have drawn. So this is very, very important. So you need to trim the arc which you have drawn initially once you join all the points with the straight line. Once you join all the points with the straight line, please trim that arc whatever you have drawn and join it with a straight line. Because it is a polygon, we need to join it with the straight line. The work of the arc is over. So this is our straight line. So once you draw all the straight lines, so what we need to develop? We need to develop only the cut portion, whatever it is there. Upper portion we are not going to bother. Only the bottom portion we need to develop. So make thick lines only for all the points below the points, whatever the lines are there, make them thick. So 5 dash to D, 6 dash to G, and 7 dash to E, and 1 dash to A. So all the points have to be marked thick. The next, join with the straight line all the points. So 1 dash to 2 dash, 2 dash to 3 dash, 3 dash to 4 dash, 4 dash to 5 dash, 5 dash to 6 dash, 6 dash to 7 dash, 7 dash to 1 dash, and the entire bottom portion has to be marked thick, because this is the developed portion once the pyramid is cut as shown by the cutting edge. So this is the bottom developed portion of the pyramid. So the upper portion should be completely thin, and the bottom portion whatever you have drawn, it should be thick, because it is the developed portion. And after completing, so show what is the length of AF. So whatever the length of AF is there, so you show it 21.17. So similarly, what is the length from D to G? So that also you need to show. The length of D to G is same, once again 21.17, and below whatever the portion which you have developed, write this as development, so that the examiner can understand which one is the developed portion. So this completes the first problem for today's class, that is on development. So next we will go for the second problem, that is on cone. The second problem is also from VTU primer. The problem number is 41 from VTU primer, and that is on cone. So I will just go through the problem statement. Please understand and refer problem number 41 from your VTU primer. The problem statement is a right cone of 55 mm diameter of base and 75 mm height stands on its base on HP. It is cut to the shape of a truncated cone with its truncated surface inclined at 45 degrees to the axis, lying at a distance of 40 mm from the apex of the cone. Obtain the development of the lateral surface of the truncated cone. Once again, I will read the question. Please understand. A right cone of 55 mm diameter of base and 75 mm height stands on its base on HP. It is cut to the shape of a truncated cone with its truncated surface inclined at 45 degree to the axis, lying at a distance of 40 mm from the apex of the cone. Obtain the development of the lateral surface of the truncated cone. So this is the problem statement. So what is given in the problem statement? The top view and front view is given. When I observe from the top, I can observe a cone of 55 mm diameter base. So it means a circular base can be observed. So this is how it is going to look. So this is how it is going to look. So when I observe from the top, I can observe what is this diameter. The diameter is 55 mm. When I observe from the front, I can observe what is the height of the cone. The height of the cone is given as 75 mm. The height of the cone is given as 75 mm and stands on its base on HP. So it is resting on HP. It is cut to the shape of a truncated cone with its truncated surface inclined at 45 degree to the axis, lying at a distance of 40 mm. So if I consider this as my axis at a distance of 40 mm, from the apex, at a distance of 40 mm, I will call this the upper point as the apex point. At a distance of 40 mm from the apex, there is an inclined line at an angle of 45 degree to the axis. So to the axis, there is an inclined line at an angle of 45 degrees, lying at a distance of 40 mm from the apex. So once this line cuts this truncated cone at a distance of 40 mm from the apex, what will be or how will be the developed part below portion? Below part has to be developed because it is given in the problem statement. How does it looks? That one we need to draw. So let us go for the construction first. So what is given in the problem statement? The top view and front view is given. So first draw the XY line. Then from the top, what is given? A cone of diameter, a right cone of 55 mm diameter of base. So 55 mm diameter means its half will be the radius. So with the given radius, draw a circle. So this may be a center point. So complete it, show the diameter. So this diameter is 55 mm. This diameter is 55 mm. So divide this circle into 8 parts. So already you know how to divide the circle into 8 parts in previous chapters. So divide this circle into 8 parts, and this is the top view. So next we need to draw the front view. In the front view, it is given that the height is 75 mm. So before going for front view, so first mark the points. So before going for the front view, name the points. So from anywhere you can start naming. So I will start with here A, B, C, D, E, F, G and H. So these are my points. So this is the center point, that is O. So the top view is over. The next thing is we need to draw the front view. So in the front view, the height is given, that is 75 mm. So draw an axis first for 75 mm and I will call this point as O dash. So from O dash, join all the points. Join all the points to O dash. So name the points. So this is A dash, this is B dash, this is H dash inside the bracket. So C dash, G dash inside the bracket, also O1 dash. The next one is D dash and F dash inside the bracket, and next one is E dash. So the height is given. The height of this right cone is 75 mm, that is given in the problem statement. And then one more thing is given. What is that? There is a truncated surface inclined at 45 degree to the axis, lying at a distance of 40 mm from the apex of the cone. From the apex of the cone at a distance of 40 mm. At a distance of 40 mm from the apex of the cone. So this is the apex point. At a distance of 40 mm from the apex of the cone, there is an cutting edge. So which cuts the cutting edge? Cuts the cone at an angle of 40 degree with axis. The angle given is 40 degree with axis. So for this we need to develop for the bottom portion. So the whatever the portion remains after cutting, the upper part we are not concentrating, we are concentrating only on the bottom part. So because it is given in the problem statement that the bottom part has to be developed. So before going for the development, what I have told in the previous problem is we need to find out, or we need to understand what is the true length first. So true length, how we need to measure? Any radial line which is parallel to XY line, so that will be considered as a true length. So OE is parallel to this XY line. Similarly, OA is parallel to this XY line. So this OE or O dash to E dash, I will consider this as the true length, or you can consider O dash to A dash also, and the true length is 79.88. This true length is 79.88. So we found out what is the true length. So once you got the true length, so first from any of the point, that is from point O, draw a true length with the given length. So the true length is 79.88. So I will draw a line from O of 79.88. So from this line, that is whatever the line you have drawn, that is the 79.88, this one you have to take as a radius and you have to cut an arc. But till what point I need to cut the arc, I don't know. So till what point I need to cut an arc? To understand that, we need to use the equation theta is equal to small r by capital L into 360 degrees. Theta is equal to small r by capital L into 360 degrees, where small r is the radius of the circle, whatever they have given. L is nothing but the slant height. L is nothing but it is the slant height. So slant height is known, that is 79.88, and the radius is given, this is our radius, and the radius is known, that is the 27.5, because so the diameter is 55, it means the radius will be half. So theta is equal to 27.5 divided by 79.88 into 360 degrees. It is going to give us the angle, and the angle is 135.2 degrees, and the angle is 135.2 degrees. I have referred the book. You please calculate whatever the value you are going to get, you have to use that as your angle. So once again I will explain. Take the true length, or draw the true length first, then taking the true length as your radius, draw an arc. But how much arc you need to draw? So to measure that, you have to use the equation theta is equal to r by l into 360 degrees. So r is nothing but the radius of the circle, l is nothing but the slant height. So radius is 27.5 and height is slant height is 79.8 into 360 degrees. I think that this value you are going to get as 123. You may get this value as 123 degrees. So from O, draw an 123 degrees line and cut this arc. So wherever the 123 degree line cuts, so that will be your end point. So now we need to mark all the points on that arc. We need to mark all the points on the arc. So I will call this as A, initial point as A. Take the radius of A and B, cut it, then B to C, then C to D, then D to E, then E to F, then F to G, then G to H, then H to A. So mine is not according to the exact scale, so the points may be here and there, but when you do it with the actual scale and the actual angle, so you are going to get the exact dimensions. You are going to get the exact dimensions. So once again I will draw it. So here you are going to get the point A. So this will be your point A. This will be your point A. The next step is join all the points to O. So B to O, join it. C to O, join it. D to O, join it. Similarly, join the point E to O, F to point O, G to point O, H to point O, and last point is once again A. So all the points are already joined. So now you can write this angle. So this angle is nothing but, it is 123 degrees. So how I have got theta is equal to r by l into 360 degrees. R is 27.5, L is 79.88 into 360 degrees. So all the points are marked now. Now we need to develop. So the cutting edge, where it is cutting the A, so here it is cutting. So wherever it cuts, and from the cutting point project it on the true length. Project it on the true length. So this is also true length only, and this is also true length, because there are two radial lines which are parallel to the XY line. So either you can mark all the points here only, or you can project all the points to this line, that is O dash to E dash. So both are correct only. You can project it anywhere you want, right? So whatever the point I have drawn here, I will project it here. So I will project it here, and I will mark this point as 1 dash. I will mark this point as 1 dash. Now measure O dash to 1 dash. Now measure O dash to 1 dash and show it or write it on the development whatever you have drawn. Next, the point is B. So B, so where it is cutting? It is cutting B here. Now project it on the true length and I will call this as 2 dash. Now measure O dash to 2 dash and place it on OB line. The next point is C. So where it is cutting C? So here it is cutting. So project it till its true length and I will call this point as 3 dash. Now measure O dash to 3 dash and place it here. So this will be your 3 dash. Next point is D. So where it is cutting D? So it is cutting D here. Project it on the true length and I will call this as 4 dash. Now measure O dash to 4 dash and place it on OD line. So this will be your 4 dash. Next point is E. So where it is cutting E? So it is cutting on the true length line only. So I will mark this point as 5 dash. So measure O dash to 5 dash and place it on OE line. Similarly, the next point is F. So where it is cutting F line? So here already you have cut or marked it as 4 dash. The same point will become 6 dash. So now measure O dash and 6 dash and mark it on OF line. The next point is G. So where it is cutting G, here already you have marked this as 3 dash. Call that as same point as 7 dash and mark it on G. The next point is H. So H it is cutting here. Already you have moved this point on the true length as 2 dash. The same point will be your 8 dash. And next point is, that is A. Already you have moved this to true length. I will call this as 9 dash and same point has to be marked on A. So now all the points have been marked. Now joining of the points. So join with the free hand. So as it is a circle, it is not a polygon. If it was a polygon, you would have joined it with a straight line. As it is a circle, join it with the free hand sketch. So I will join 1 to 2, then 2 to 3, then 3 to 4, then 4 to 5, then 5 to 6, then 6 to 7, then 7 to 8, then 8 to 9. So I have joined the points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash and 9 dash. So once you join all the points, the bottom portion has to be made thick. So actually only A and E are the two thick lines. The other lines should be thin because we are drawing these lines, other lines, that is nothing but B, C, D, F, G and H. We are drawing these lines for our easy drawing purpose, right? Actually only this A dash and E dash, these lines are visible. So observe here, when you observe a cone from the front, only two lines will be visible, right? Only two lines will be visible. But we have drawn all these lines, that is B, C, D, F, G and H for our convenience, so that we can draw all the points very easily. So that is the reason why we have drawn them. So actual visible lines will be only two lines. So it means only the visible lines has to be made thick. The other lines, it is not necessary to make it as thick. So it means the portion which you have to make thick is only this much. So this has to be thick. So this entire arc has to be thick because it is the developed portion. So this part has to be thick and this cut portion also has to be thick. So this only this much part has to be made thick. So it is not necessary to make the thick lines which you are getting inside of this cut portion, because these are not actual lines. These lines we have drawn for our easy convenience purpose. So we have to draw only these two outer lines and this portion. So what I have drawn thick is only this portion I have drawn thick. Only this portion I have drawn it as thick. So that has to be shown as thick lines. And this completes your problem, and whatever the developed portion is there you can write it as development, development. So this is the development. So this is the cone which was given. So after cutting this cone, so what will be remaining? So this will be the remaining portion. Only this will be the remaining portion. So that remaining portion, when you cut and you open it, how does it look? That what we are going to draw in case of development. And one more thing what you have to remember in case of cone is this particular formula. This particular formula you have to remember very carefully. So that is nothing but theta is equal to r divided by L into 360 degrees, where r is the radius, the diameter is given for this case, that is 55 mm. So it means radius will be half of the diameter. So it is 27.5 divided by L. L is nothing but the slant height. So for that you need to measure the true length. So the true length value has to be entered here, multiplied with 360 degrees. So you are going to get the angle as 123 degrees. So first draw the true length, that is the 79.88. Then taking this as radius, draw one arc. Then measure what is the angle. So keeping your protractor at this point, draw the angle whatever you have got till it cuts the arc which you have already drawn with the true length. So once it cuts the arc, so that will be the end part here. Then measure all the points. So first mark the point, this as A. Once you mark A, measure A to B and cut an arc. Then B to C, cut an arc. C to D, cut an arc. D to E, cut the arc. E to F, cut the arc. F to G, cut the arc. G to H, cut the arc. And H to A, cut the arc. So once you cut the arc, then place all the points. You are already will be having the cutting edge. Place all these points which is cutting on the lines A, B, C, D, E, F, G, H, and all the points has to be placed or relocated to true length. So measure that true length from the apex point and go on marking the points. Once you mark the points, join all the points with the freehand sketch. Once you join all the points, then the bottom portion will be the developed portion. So this completes the second problem on the development. And in today's class I have completed two problems. One will be on pentagonal pyramid and another will be on the cone. So if you have any doubts, you can call us and clarify your doubts anytime. And for your syllabus for internals, which is coming in the next week, the syllabus will be the solids, projection of solids, and also the development part. So in the previous class you have gone through two problems on development of lateral surfaces. Today's class you have understood two problems on the development of lateral surfaces, and there will be one more session on this chapter, that is the development of lateral surfaces. In that also two problems will be solved. So totally you will be having 6 solved problems, and remaining problems you can solve it in your home. And if you have any doubts, you can call to your class graphics teacher and you can clarify your doubts. Okay. So this completes today's session on development of lateral surfaces. Thank you.